Alrighty, folks, one last problem on this section here. We're looking at number 33. I tried to pick problems that looked kind of scary on the practice, so just to kind of give you guys an idea of what tactics you might employ. So we're going to solve this indefinite integral using u substitution again. And if again, remember, most typically u is going to be the inside function here. So the key, I think, with this problem, the reason I chose this is because you have to recognize where the inside function is. So hopefully you were able to rewrite this here. And if you look on the text here, we know the answer is 1/7 times the natural log of x to the 7th plus c here, right? So we're going to rewrite this function here first as the indefinite integral of ln of x to the 6th power over x dx. And hopefully now, looking at this, it's rather obvious here as to which one is, he has a scratch on his eye, as to which one is the inside function here, right? So clearly we can see that we have two functions, actually three. We have ln of x, we have 1 over x, there's a 1 over x, and we have to the 6th power, something to the 6th. So the inside function is what is inside, and ln is on the inside. Now, it doesn't always work that way. In other words, what I'm trying to say is u substitution, you have to try different functions depending upon the problem. This one is relatively straightforward, but not every single problem will work out with the first substitution. So you might have to try more than one, so just be aware of that. So we're going to go ahead and try here. So let's just say I let u equal ln of x, right? So let's go ahead and try that here. So u is ln of x here, right? So then I'm going to, when I take the derivative, I'm going to get that du is, the derivative of ln of x is 1 over x times dx here, right? And hopefully now, as you're looking at this and you're just thinking to yourself, and hopefully a light bulb kind of goes off in your mind. Why? Because you have here du is equal to 1 over x dx, and that's almost exactly there. Hopefully you can see it here. There is an invisible 1 here, right? So this whole thing, we can substitute in this guy for du, right? So I'm going to rewrite this problem now over here, and so I get the indefinite integral of ln of x to the 6th. Remember, ln is u, so I'm going to put, instead of ln of x, I'm going to put u to the 6th, right? And then times, I have 1 over x dx here, and that whole thing is this, which is just what? That's just du, right? So I'm going to rewrite it again so it's prettier. So I have the indefinite integral of u to the 6th times du. Well, I can, now I'm really happy because I can now integrate this guy here very easily using the antiderivative for a polynomial function. So we add 1 and multiply by the reciprocal. If I add 1 to this, that gives me 7. So it's going to be u to the 7th times the reciprocal, which is 1/7. Don't forget your plus c because it's the indefinite integral. And now I'm going to plug in my limits of integration. Excuse me, not plug in limits of integration. I'm going to resubstitute what u was. And if you recall, u was ln of x. So I get 1 over 7 times the natural log of x to the 7th power, right, plus c. And you can also rewrite this as they did in the book. Oh, not in the book. This is actually the answer they have in the book, but you can also rewrite this as 1 over 7 times ln of x to the 7th. That's the same thing, plus c. You get the same thing, which is the same thing as ln of x to the 7th over 7 plus c, right? All of these are equivalent answers here. Good job.